Good morning. Today we'll start the next application of derivatives, which is errors and approximations. It helps us to find the approximate values of functions which otherwise may not be very simple. Also, it helps us to find the errors in measuring certain quantities and helping us to do the calculations. So let's start from the very basic. Let's take up the procedure of doing that. So consider the function y equal to fx. Let its graph be, or the curve which corresponds to this, be something like this. So we draw the curve y equal to fx. Consider a point P having coordinates xy on this curve. If we give a small increment delta x to x, so that the new point has the x coordinate x plus delta x, the corresponding y coordinate will become y plus delta y. So on giving a small increment delta x to x, we reach another point Q having coordinates x plus delta x comma y plus delta y. And as we are already aware, the ratio of the difference in the y coordinates to the difference in the x coordinate gives us the slope of this line PQ, and in the limiting case the slope becomes the slope of tangent to the curve at P, and which is also called as the derivative at the point P. So let's write that. So dy by dx is the limiting case as the increment delta x tends to 0 of the ratio of the change in y coordinate to the change in x coordinate. That is, it is a limiting case of delta x tending to 0, delta y over delta x, that is a change in y with respect to the change in x. If we drop this limiting sign, dy by dx will be approximately equal to delta y by delta x. So we write dy by dx is approximately equal to delta y by delta x. Taking this delta x, now this is simply a ratio. You can take the denominator to the other side. So this gives us delta y is approximately equal to dy by dx into delta x. Now we know that just now we have seen that if we give a small increment delta x to x, so that x becomes x plus delta x. If we write in terms of y equal to fx, we will see that fx becomes f of x plus delta x. So you can use any of these notations. Either you can use this which is equal to y plus delta y. So either you use y plus delta y or you use f of x plus delta x. They are one and the same things. Now let's see what kind of questions we can do using this. So if we have, suppose the question says find the approximate value of square root of 36.6. Now we have seen, we can easily see that we know the square root of 36, which is a perfect square, but finding the square root of 36.6 may not be very easy. Like directly we cannot do it without going through that cumbersome procedure of finding the square root. So what we do is we start in this manner. We consider the base function y as square root of x. Okay, because here we are required to find the square root. So square root of x, we define we consider the base function y equal to square root of x. Now we can find now we look for that value of x which is a perfect square, whose square root can be directly found out, and which is the nearest value or the closest value to this 36.6. So the closest perfect square is 36. So let we consider x equal to 36 and let delta x be equal to 0.6, so that we can find square root of 36.6. Now let's see how it works. So to find square root of 36.6, we have x is 36. delta x is 0.6, and now first of all we find the value of y. Y would be what? When x is 36, y is root 36, which is equal to 6. So therefore square root of 36.6 becomes y plus delta y. But we have already seen that delta y is approximately equal to dy by dx into delta x. So y plus delta y is approximately equal to, y remains as it is. In place of delta y we will write dy by dx into delta x, where y is square root of x. So we have dy by dx will be 1 upon 2 under root of x. At x equal to 36, dy by dx becomes 1 upon 2 into root 36, which is 1 upon 2 into 6. Therefore, substituting, we get square root of 36.6 is equal to y plus delta y, which is approximately equal to 6 in place of y, plus 1 upon 2 into 6, which is delta y, into delta x is 0.6. So you write it like here. So this comes out to be 6 plus this gets solved to 0.5, so that root of 36.6 is approximately equal to 6.05. So we have seen, without actually having to go through the process of finding square root, we can directly in 2-3 steps find the square root of 36.6. Let us now start with exercise 6.4. So let's take up the first question, which is find the approximate value of square root of 25.3. Now again, this is a square root function, so the baseline function which we will take as, let y equal to square root of x. Okay, so now here what the nearest perfect square is 25, such that x is equal to 25, okay, which implies that y is equal to square root of 25, which is 5, okay, and delta x is 0.3. So therefore square root of 25.3 is nothing but y plus delta y, okay, but y plus delta y is approximately equal to dy by dx into delta x, and so square root of 25.3 is equal to y plus delta y, which is approximately equal to y remains as it is plus dy by dx into delta x. Now y equal to root x, it implies that dy by dx is equal to 1 upon 2 root x. At x equal to 25, y equal to 5 as we have seen above, and dy by dx equal to 1 over 2 into 5, which is 1 over 10. Delta x is 0.3, therefore square root of 25.3 is approximately equal to, now y is 5 plus dy by dx is 1 over 10 into delta x is 0.3. Now we need to solve it, so this will be equal. Now here we use the approximation sign, but here on the so slightly to the right we will write equal to, because this is equal to what we are going to do now. So this will be equal to 50.3 upon 10, which is equal to 5.03, and so we get square root of 25.3 is approximately equal to 5.03. Now in the same way you can do question number 2. The third part is square root of 6. So I am taking the third part, which is square root of 0.6. Now here Again, the underlying function is the same, square root of x. Okay, now here, what should be the value of x which we should take? The first thing which comes to our mind is we can take x as 1, which is a perfect square. But the difference between 1 and 0.6 is considerable. Okay, and delta x needs to be extremely small. It's a small increment. Okay, so we have to look at a nearest perfect square. So here the nearest perfect square would be 0.64. If you see, it's a square of 0.8, and so that y becomes equal to square root of 0.64, which is 0.8, and delta x is equal to minus 0.04. Now if you just see, x plus delta x will become 0.64 minus 0.04, which is 0.6. Now this is 0.04 is very small as compared to 0.64, and so we take this rather than taking x as 1. Now therefore square root of 0.6 is equal to y plus delta y, which is approximately equal to y plus dy by dx into delta x. Now y is equal to root x, which is gives us dy by dx is equal to 1 over 2 root x. At x equal to 0.64, y is equal to 0.8, and dy by dx is equal to 1 over. Now we have dy by dx 1 over 2 into root x, which is y, is 0.8. Okay, therefore we have delta x is minus 0.04. So we have square root of 0.6 is approximately equal to y plus delta y, which is equal to what? Y is 0.8 plus delta y is dy by dx, which is 1 over 2 into 0.8 into, now here you have to be very careful, the increment is negative, so we have to make use of this negative sign. Solve it, we get this goes, you are left with point here. Now this gives you 0.1, this gives you 2 times, so this is equal to 0.8 plus, this is what? No, minus, because of this minus sign you will have this minus 0.05. So this is equal, this gives you, this is equal to 0.75, and this is the answer. So we have square root of 0.6 is approximately equal to 0.75, which is the answer. Same way we can even find the cube roots or the 10th root or anything of that sort. So let's see this. Question number 1. Let's take up the fourth part. Fourth part says that we have to find the cube root of 0.009. Now the nearest cube is 0.008. So let y is equal to the, now the underlying function is cube root function. So cube root of x, where x is equal to 0.008 and delta x is equal to 0.001. Now we'll find, so 0.009 whole, this will be equal to y plus delta y, which is approximately equal to y plus dy by dx into delta x. Now when x is 0.008, y is 0.008 raised power 1 by 3, which is equal to 0.2. Now this is this. Also dy by dx is equal to 1 over, now what do we have? The derivative of this would be 1 over 3 into x raised power minus 2 by 3, okay, which is equal to 1 over 3 into x is what? X is 0.008 raised power of minus 2 by 3. So what we do is 1 over 3 into, first of all we find the cube root, so this is equal to 0.2 whole raised power minus 2. You take it to the other down, it becomes 3 into 0.2 whole square, which is equal to 1 over 3 into 0.04. now therefore 0.009 is approximately equal to y. Y is equal to 0.2 plus dy by dx, which is equal to 1 over 3 into 0.04 into delta x is equal to 0.001. This gets cancelled, you are left with point here. Now solve it. It is equal to 12 into 2 is 24 plus 0.1 upon 12, which is equal to 2.5 over 12, which is equal to 0.25 is 2 times 0, and then you will have 9 approximately. So we have 0.009 and the cube root of this is approximately equal to 0.09, which is the answer. Same way, let's take up question number 5. Question number 5 says that 0.999 and the 10th root of this. So the underlying function would be equal to y is equal to x raised power 1 by 10. Now the 10th root, how do we find? So clearly the nearest 10th power is 1. So where x is equal to 10 and delta x is minus 0.001. So 10 minus 0.001 is 0.999. Now we find 0.999 raised power 1 by 10 will be approximately equal to y plus delta y, which is equal to y plus dy by dx into delta x. Now let's find all these values. Now y is equal to x raised power 1 by 10 implies that dy by dx equal to 1 over 10 x raised power minus 9 by 10. Now this becomes equal to, now at x equal to, x is not 10, x is equal to 1. Now at x equal to 1, we have at x equal to 1, y will be equal to 1 raised power 1 by 10, which is 1. And dy by dx will be equal to 1 by 10 into 1 raised power minus 9 by 10, which is 1 by 10. Therefore, the 10th root of 0.999 is approximately equal to y is 1 plus dy by dx is 1 upon 10 into the increment is minus 0.001, which is equal to 1 minus 0.3 times 0, 1, which is equal to 0.9999. So approximate value of the 10th root of this is equal to 0.4 times 9. This way you can try the remaining parts of question number 1. Thank you.